Okay, so again in this video we're in section 1.3 from your book, working with one-to-one functions. And so for this example I'm going to prove that a function is not one-to-one. So the function got x squared minus 3, and I'm taking this from the set all real numbers to the set negative 3 to infinity, and I'm going to show this is not one-to-one. So just to kind of refresh, again, this is in the book, but this first line here is the definition of what it means for a function to be one-to-one. And so a function is not one-to-one if this statement is false. In other words, if we take the negation of this statement, and they go through in your book how to get to the negation. I skipped all of that, but the negation looks like this. So what we're trying to show is that this statement is true, that there exists an x1 and an x2 in the domain, so that if we set f of x1 and f of x2 equal, that we have that, but we also have that x1 and x2 are not the same. So really what this means is I'm trying to find two different x values in the domain that when I plug into the function are equal. So if I can maybe think in those terms, can I think of two x values in the domain that I will plug into the function and still give me the same function value or y value? So I might start with just a little bit of scratch work before I actually write out the proof. And so what I'm really after is, can I figure out these two x values that aren't the same, but that will give me the same y value when I plug into the function? And so what I'm going to do is I can really pick any number from the range. Now I thought about this for a minute ahead of time, and so I'm going to pick a number that makes everything work out nice and neat, and I think you'll see how I maybe thought to chose this. But ultimately it was just random. I'm going to set the function equal to 13. So just pick any number from this set y and set the function equal to that. And if I take this and solve it for x, add 3 to both sides, and then I can take the square root. And since I get a positive or negative, this really gives me my answer, because what this says is that if I take x equal to positive 4, the y value will be 13. On the other hand, if I take x equal negative 4, the y value will also be equal to 13. Okay, so I can use this information to write up my proof that the function is not one-to-one. And so if I do that, I'm going to say that I'm going to pick x1 to be 4 and x2 to be negative 4. And if I can show that I get the same y value when I plug both of these into the function, then that's all I need to prove that the function is not one-to-one. And so plugging positive 4 back into the function x squared minus 3. So that would be 4 squared minus 3, which is 13. And if I plug negative 4 into the same function, since a negative squared is positive, that's the same number, that's 16 minus 3, which is 13. And that's really all I need to say that my function is not one-to-one. And So not a ton of work there to get to the conclusion, but that's all you need to show in order to prove that a function is not one-to-one.